Now here is the next question. A 5, minus 2 and B 2, 4 are given. Point C lies on y equal to 1 plus x square. Find the equation of centroid of triangle ABC. So here if we see, we are given 2 points, which is A 5, minus 2 and B, which is 2, 4. So these are two fixed points which are given to us. Now there is some point C which lies on a particular curve. So that means C is a moving point or variable point. There can be any place where that C can belong on the curve. And the equation of that particular curve is given as 1 plus x square. Right? Now if we join the points and make a triangle ABC, we want to find the locus of the centroid of triangle ABC. So here by equation of centroid, it is actually equation of locus of the centroid of triangle ABC. That is because, like, if you consider some other position of point C on the curve, then what will happen is it will create a different triangle and it will have a different location of centroid. So for every such triangle, the centroid will also keep on moving. So we want to find out what is this particular locus, that is what's the equation of this particular curve on which the centroid of all the triangles lies, right? So coming back to the given data, alright, as we have seen, the point whose locus we want to find, we assume that point as h, k. So let us assume that this G be having the coordinates h, k. Now if you observe, C is also a varying point, a moving point. So therefore let's call its coordinates as A and B. Alright, because here we cannot use h and k again. So therefore we have used A and B. Now to find the locus of centroid means we want to find the relation between h and k, isn't it? So we must try to look for how we can write the conditions in terms of h and k. Now since we know the coordinates of centroid can be calculated using the formula. So x coordinate of the centroid is nothing but sum of x coordinates of 3 points. So that is 5 plus 2 plus a whole upon 3, isn't it? And y coordinate is also similarly sum of all the y coordinates of 3 points whole upon 3. So therefore this gives us 3h is equal to 7 plus a and 3k is equal to 2 plus b. Or if we want to write a in terms of h, then that is nothing but 3h minus 7 and b is nothing but 3k minus 2. Right. Now since we want to have the relation between h and k, in other words, it means that we should eliminate a and b from the scenario and connect only h and k. So let us ask the question, what is that condition we can use to relate a and b? So a and b are the coordinates of point C, isn't it? And C lies on this particular given curve. So therefore, obviously, if we substitute the coordinates of C in the given equation, then we can automatically replace a and b in terms of a and h, right? So therefore, this particular equation gives us y coordinate of C is nothing but b, that is equal to 1 plus, now here the x coordinate is nothing but a, so therefore it is 1 plus a square. That's it. And lastly we replace a and b in terms of h and k. So therefore putting b as 3k minus 2, we have 1 plus 3h minus 7 plus 3h minus 7 the whole square. So therefore we have 3k minus 2 is equal to 3h minus 6 plus 9h square minus 42h plus 49. So therefore we have, on the right side we collect the terms of h square, which is a single term. Then if you consider the h terms, it is 3 minus 42, so that gives us minus 39h, correct. Then let us collect the k terms. So k is 3k on left side, so that will become minus 3k on right side, and you have 49 here, minus 6, which gives us 43, and this minus 2 will become plus 2 there, so 43 plus 2 is 45 equal to 0. So we can cancel out a factor of 3, so therefore on cancelling 3 we have 3h square minus 13h minus k plus 15 is equal to 0. So as we have got the simplest expression involving h and k, now we can replace h with x and k with y to give us the final required equation of the locus. It is 3x square minus 13x minus y plus 15 equal to 0 is the equation of locus of centroid G. So this is the curve on which all the different centroids of different triangles will lie.